Econometrics in practice, level 2. In level 2 we will discuss instrumental variable regression, regression discontinuity designs, difference in difference estimators, and some other things. So it's better to complete, listen, watch previous videos and practice. So what are instrumental variables? What are assumptions of instrumental variables? How can we apply instrumental variables to real life problems? From where we get relevant instrumental variables? There will be 4 to 5 videos on instrumental variable regression. Please watch these videos to understand this and read Stock and Watson chapter 12 to follow this. You see, we have discussed internal and external validity of a regression model in one of the video. I'll provide the link in this video as well. 3 threats to internal validity. Out of those 5, omitted variable bias, you don't have data on a variable, it's unobservable. Simultaneous causality, that test score, basically when you get poor test score, you hire more teachers. This will reduce student teacher ratio. So student teacher ratio decrease is because of low test score. So whether test score is going to be determined by class size or class size is going to be determined by the test score, we don't know. Whether foreign direct investment leads to more GDP growth or more GDP growth leads to more foreign direct investment, we don't know. And if your X variable is not measured, if X variable is measured with errors, in all these scenarios, your X variable is correlated with U, which means your basic assumption that X and U are uncorrelated is violated. Now, what is name of the game? Name of the game is that we need to differentiate, we need to separate the effect of U, X from U, which is uncorrelated. Basically, X and U are correlated, but some part of X is uncorrelated. We need to find out that part, and for that we need to find a variable, a proxy for X which is correlated with X but uncorrelated with U. That variable, if it satisfies this condition, then that variable is called instrumental variable. So before I go further on instrumental variable, 2 important concepts: endogeneity, exogeneity. Literal meaning, endogeneity determined within the system, exogeneity determined with the outside the system. And very simple definition: a variable X correlated with Y is endogenous, a variable X correlated with U is endogenous. First, endogenous is correlated with U, exogenous, which is uncorrelated with U. But for more comprehensive study, understanding of endogeneity and exogeneity, read chapter 5, Dynamic Econometrics by David Henry. Basically, it's a very useful concept, but very difficult. Strong exogeneity, super exogeneity, weak exogeneity. Anyhow, we can't go in that detail at the moment. That will be level 3 of econometrics, where we may discuss these things. Okay, let's go. X is basically now correlated with U. We need to find out that part of X which is uncorrelated with U, and then we'll replace that part of X here. So how do we achieve that? We need to find a variable Z which is correlated with X but uncorrelated with U. If these 2 conditions are satisfied, we say Z is a relevant instrument. Z is a relevant instrument. So what do? There are 2 stages. Another thing which we are going to discuss here is 2-stage least square. First of all, we are going to regress X on Z. So from this we get X hat. So you see, when we regress Y on Y hat, Yi is always equal to Y hat plus U hat. And U hat is basically Y minus Y hat. So this y hat is that part of y which is uncorrelated with u. So x hat will be equal to x hat plus u. X hat will be that part of x which will be uncorrelated with u, and that's our name of the game. That is, x hat is equal to pi naught hat plus pi 1 z. So we get x hat at first stage, and at second stage we regress y on x hat. Now this x hat is uncorrelated with u because you have decomposed x into two parts, x hat plus u hat. This x, basically from u hat x minus, basically this x part, this has been eliminated from u, so it means u and x hat are independent of each other. So this is second stage, so that's why we call two-stage least square. Okay, fine. Well, let's go. Let's move. This will be my video number 1, which will be about just the basic concepts. Regress y on x, x on z, regress y on x hat, you will get beta 2SLS. It's two stage, that's why we call. No, use in place of covariance between y and z, you see y is replaced here, z. So beta naught is constant, covariance of beta naught and z will be 0. This beta 1 is pre-multiplied, so its parameter constant, it may come outside this one, and covariance between u and z by assumption is 0. So beta 1 is equal to covariance of z divided by covariance of x and z, y and z divided by this one. When you, this is population, we don't have population data. From sample we have sample covariance, this is called beta 1 hat 2SLS. So when you have large sample size, beta 1 hat approaches beta 1, this is called consistency property due to large numbers and all that. Now, let's take an example to understand what is simultaneous causality. You see, quantity of butter is basically, this is a long story that basically Sewell Wright and father and son, basically Phillips Wright and Sewell Wright, basically they try to determine tariff barrier on oil and products. So quantity of price is function quantity is function of price, and you see, as we see that both supply and demand are determined within the prices, and the supply and demand determined within the system. So both these two are endogenous variables. And what happened, you have a demand here, we have a demand here, Q, P, this is my demand level 1, D1, and supply level is this one, equilibrium point is this one. No, due to increase in income, let's say demand level increase, so supply level is remains same, this one. But if supply decrease, you will have a different point. If supply again increase, demand further increase, so you have this one, this one, this one, all these are equilibrium points. When I trace it here, so you will have these points which I showed you here. So from this, you can't say that it's a demand equation or it's a supply equation. Observationally, they are equivalent. Observationally, they are equivalent. So what Wright, father and son, whether son or whether father, I don't know who thought this idea. Basically, there is a controversy in history of giving credit whether to father or to son. So basically, they thought that try to find a variable which affects supply but not demand. They thought that rainfall is a variable which affects supply, as in subcontinent we see tomato and onion prices. They are basically supply determined. In general, tomato and onion demand in Pakistan, Bangladesh, India, that remains more or less same, but supply is linked with the weather and season as well. So if a variable helps to shift supply but not demand, what will be the case? You see these blue points, that will be a demand equation. These 3 points, that will be a demand equation. So they basically try to find a variable which was uncorrelated with price but helps to determine you see price. No, price is rainfall. Sorry, rainfall is uncorrelated with other factors which affect price, but price and rainfall are correlated because lower the rainfall, less the supply, more the price. So therefore they are correlated. So they try to find out a factor which affects supply but not demand, and in this way it's correlated with price. Sufficient rainfall means less grazing, means less butter, means higher price. So okay, no, you see, in first stage we'll regress price on rainfall, and then at second stage we'll regress quantity of butter on price of butter. Okay, I'll make it simple in coming slides. Okay. No, this is another story. You have class size and test score, and you see if there is an earthquake, as in 2005, India, Pakistan has very serious earthquake. Those schools which are close to the center, the schools which are close to the center, basically they may have close to the epicenter of earthquake. The buildings which survive will have more class size, but they are unrelated with other factors. So you may consider earthquake as an instrument for class size, and this is uncorrelated with U but correlated with class size, and earthquake epicenter has nothing to do with other characteristics of parents' incomes and all that. So therefore this may be considered as a valid instrument. Okay, let's move further. Okay, this is the example which I was giving. Okay, let's inference. Inference about 2SLS is very simple. For large sample theory, central limit theorem comes into play, and your standard statistical inference for large sample is same as for multiple linear regression models. You see, this is SYZ, which is sample mean, and sample means follow normal by central limit theorem. So therefore, our standard statistical inference will remain same, that beta hat 2SLS follows normal with mean beta 1 and variance beta 2SLS. Inference using 2SLS is more or less same. Only difference is that you need to take care of standard errors. Don't take standard errors of second stage. Rather use two-stage least square directly instead of estimating it one by one, because when you estimate first stage least square and then you estimate second stage least square does not incorporate first stage least square standard errors into second stage. So there may be slight you see error in calculation of standard errors. So when you apply two-stage least square, directly use your stata commands, R commands, and other software commands. So what do we say here? Okay, this is our problem for this chapter, that we'll try to find cigarette demand as a function of price of cigarettes, whether increase in prices leads to lower demand in cigarettes. This is basically beta 1 is elasticity. This depends upon the elasticity. What is elasticity? But this price is also correlated with other factors. So therefore this price may not be exogenous. So we need to find out some instrument, and that's what is our research question for this chapter. We'll try to find out the answer of this question, whether increasing cigarette prices leads to lower in demand of cigarettes. So you see sales tax, general sales tax at the national level increases prices, but it is uncorrelated with some other factors. So therefore it may be a valid instrument. Or cigarette specific tax, that we'll talk in our next video. And it is uncorrelated with other factors. So two conditions are satisfied. If sales tax is correlated with prices and uncorrelated with the other factors, so we say that it is basically relevant, and it is exogenous sales tax. So at first stage, we'll regress cigarette prices on sales tax for 1995 data of US states. This is 7 years, 8 years data, but we'll first of all use only for 1 year data. So at second stage, you will have this one. No, minus 1.08 will remain same whether you estimate one stage, second stage, or you estimate it directly by two-stage least square, but standard errors may change, sometimes by a small magnitude, sometimes by a large magnitude. So in this case, if you regress X, that is average cigarette prices on cigarette taxes, and second stage, you estimate X hat price of per packet on price per packet of quantity of per packet on price per packet. For year 1995, you will have two-stage least square. 0.33 will be your standard error. But when you use instrumental variable regression in Stata, and similarly we'll use in R, and I'll demonstrate it, then you get slightly different standard errors. So though this difference is very small in this case, but it may be large at others in other cases. So therefore, please use two-stage least square directly like this way instead of using stage by stage. So that's what is the main message. I'll try to summarize this. What I am saying that you must have a relevant variable which is uncorrelated with X. It should be which should be correlated with X. It should be uncorrelated with Z, and U should be uncorrelated. Two-stage least square will be used. At first stage, you will try to get X hat, and at second stage, you will regress Y on X hat instead of regressing Y on X as in OLS. Standard statistical inference remains same. Instead of using the estimation one by one, stage by stage, use two-stage least square directly. So I hope this will help you in understanding the basic concepts of instrumental variable. I will demonstrate more on it because you see, cigarette demand is function of prices, but income is not there. Income has a role. So we'll discuss all these things in detail, from where these valid instruments come from, what is weak instrument, what is strong instrument. We'll apply some tests as well, and we'll explore the concept of instrumental variable regression with the help of data very rigorously. Thank you for watching. Take care.